So I'm going to keep the intro short because we've got quite a lengthy lecture coming up. Because what we're going to be doing in this lecture is getting our tank to the stage where it can actually drive itself. Look at this. So here is my tank, and if I apply control input, I can rear it up, I can drive backwards, I can turn around, and all that good stuff. So we're going to be implementing all of that in this lecture. And how we're going to be doing it, let me just give you a quick overview. We are going to be exposing an add driving force from the wheels themselves, and then we are going to be updating drive track so that we apply force through all of the wheels that are attached. In order to do that, we're going to need a get wheels method that gets hold of all the wheels that a track has, and we're going to be updating some of the code, etc., etc. And we're going to go on to basically implement in a challenge that get wheels, getting hold of all the wheels that a track has so that we can apply the force to them. Without further ado, let's dive right in. Now, it'd be really awesome if I was actually able to drive my tank. If I go ahead and hit play, at the moment, I can do nothing. I've got my controller here, clacking away, and nothing is happening. So the way that I want to implement this is from the bottom up. I want to be able to apply forces through the wheels that allow us to drive. After all, the force is happening there. That is the kind of contact point and where we should be applying forces. So that's what we're going to do. First of all, we're going to do some follow along, and then I'm going to challenge you for the last piece of this puzzle. So do follow along with what I'm doing here. I'm going to be talking you through. So get your editor open and your Visual Studio going. Okay, first of all, we're going to expose add driving force. What do I mean by this? Well, on our sprung_wheel.h, I want to expose a public method that allows us to say drive this wheel forward. So what I'm going to go is go to the public section that we've got here. In fact, this is a little bit messy. I'm going to bring the public sections together. For some reason, it puts them in a funny way, but I don't want to do that. Instead, what I'm going to do is I'm going to group the constructors together and put tick at the top, and then I'm going to put my public methods. So I'm going to start off with a void, because it's not going to return anything, add driving force, and it's going to take the force that we want to apply, but it has no direction because the direction is implied by the wheel. All we need to tell it is whether we're going forward, we're trying to rotate the wheel forward, or backwards. So that can easily be done with a float that can be both positive and negative, and I'm going to call this the force magnitude because it has no direction, and that's the general idea of the force there. So let's go ahead and implement it over in the C++. Now, this is fairly straightforward. You want to be applying a force in the direction that the wheel's going at the current location of the wheel, which obviously can change depending on the spring. So you could have a little go at implementing this yourself. If you want a mini challenge, you can pause and try and implement it. Okay, so what I'm going to do is I'm going to be applying a force directly to the wheel component. After all, it is constrained to the tank body, so any force we apply to it is going to eventually, through the constraints, lead up to the tank. So I'm going to do a wheel arrow, add force. You've added forces before. The force obviously needs a direction. It can't just be a magnitude. So what is the direction? It's going to be the forward direction of, in this case, I think the axle is probably the best thing to use the direction of. I think that's going to be vaguely pointing in the right direction. So we're going to do axle get forward vector. I'm going to multiply that by the force magnitude that has come in here. Okie doke, and that should be enough. We are already going to be applying a force. Obviously, we'd ideally only apply a force when this wheel is actually on the ground. We're going to deal with that later, but not just yet. So that's exposed driving force. Next up, we need to go through and apply this driving force to every single wheel on a track, because if we remember how it's done at the moment, we've got our tank track, and on there we are setting the throttle, and then that is applying the force. So if we go over to the C++ of tank track, so tank track CPP, you can see that we've got our set throttle, we've got our drive track. We now want to update drive track to work a little bit better. So I'm going to need a way of getting hold of the wheels, and for now I'm going to just skim over that and create just the definition of what that method's going to look like. So it's going to be under private. I'm going to make it return a T array of a sprung wheel pointers, like so. I'm going to have to forward declare that because I'm not including that yet. And then this is just going to be a get wheels method like so. Okay, so that's what we want. Eventually we'll implement this. In fact, let's make it const as well, because it shouldn't, by calling this, shouldn't change this class. So let's go back over to the C++. Now what we want to do is apply this force to every single wheel. So we don't need a direction anymore to this force applied. So let's remove the direction. So it's just the current throttle multiplied by the max driving force. We don't need a force location. We don't need the tank route or any of that stuff. What we do need to do is get hold of our wheels. So we're going to do, just going to store that into an auto variable because I can't be bothered to type out that whole TRA thing again. Let's call it wheels. There you go. And then we want to know how much force to apply to an individual wheel. Now, an easy shortcut for us to do here is just create a auto force per wheel, which is just going to be the force divided by the number of wheels that we have, which we can get by doing a wheels.num, like so. So now we've got a force per wheel. We need to go and iterate over every single wheel. Do it with a for loop, so for over, and it's going to be a sprung wheel pointer, and I'm going to call it wheel over the wheels TArray. That's a for loop over the wheel TArray. Then we're going to do wheel arrow, and we're going to add, and hopefully, we need to do an include so that we can actually use the implementation here. So it's going to be include sprung wheel.h, and then we're going to add driving force. Perfect. And then if we've got all our types right, force per wheel should be a float, and we should be able to use that as the argument. Perfect. So that's gone ahead and shown us what the requirement is going to be for get wheels, and we've created that drive track. In fact, we have updated drive track already to apply for all wheels. That's perfect. Next, we've got a bit of legacy code here in TankTrack because it is doing its collision management. In here, we're going to do the collision management in wheel instead. So let's go ahead and remove this collision management. You can see that on hit, we're driving the track. We no longer want that to happen. What we'd rather happen is that when we set the throttle, it instantly tries to drive that down to the track, push it down to the track. So I'm going to drive track here and set throttle. And in fact, now you notice that we no longer really need current throttle to be a member variable. So instead, what I'm going to do is I'm going to remove it as a member variable, and I'm going to add in to, let's see, drive track. It's now going to have the current throttle as an argument to drive track. I'll do that over in the C++ as well as the header file. And so that's where it's going to get current throttle from. And then we want to store this float in set throttle. We want to store current throttle into a local variable and pass that into drive track, like so. And we don't need to do current throttle plus throttle anymore because we don't have a previous throttle value. We've only got what's coming in from this set throttle. So this will work in very much the same way as it was doing before. And I think I've removed the variable, so that's all going to work fine. We also want to remove this apply sideways force because, as we've seen in the previous video, using our wheel constraints, we're able to do that in a much more elegant way. So we can remove apply sideways force. We can also now remove on hit because we no longer need to reset the current throttle or drive the track from there or apply the sideways force. So that's no longer needed. So we can remove that. We can remove the on component hit add dynamic in begin play. In fact, we could even remove begin play if we want to. So I can go ahead and remove all of those things. That's great, and I can do the same from the header file, remove on hit, apply sideways force, all that's going, and so is begin play. So we've really stripped down the tank track to the bare necessities, which is really nice. Okay, so it is applying force through the wheels, and we're doing that through set throttle. I'm pretty happy that that's what we've got. We've refactored a little bit as we went along. Okay, so what we now need to do is implement get wheels. So how do we iterate over child components? That is the question, the million-dollar question. Well, any uScene component, so any component basically that can have children, has got this function called get children components linked in your resources. If you pass in a bool as the first thing, which says, should I include all the descendants or just the first level hierarchy? Should it be grandchildren, great-grandchildren, etc., or just the children? If it's false, it's just children. Otherwise, if it's true, it'll include everything. And then you pass in this out parameter of children, which is a t-array that you'll have to set up outside, and it then populates it with all of the children. Now, obviously, this isn't necessarily going to get all the wheels, so you would have to make sure you are getting hold of just those spawn point components, and then somehow from the spawn point components you need to get the actual wheel actor that it spawned. So you may have to change the way that component works a little bit to give you a better API to access that. So that is going to be your challenge indeed, to implement get wheels using that knowledge from the documentation. So spawn point should have a getter that allows you to get hold of the actor that it generated, and wheels spawned by this track should be returned by get wheels. So it's going to return all the actors that were spawned by this track. So we've currently got 2 on each track, or at least I have, and we're going to add more later on. So this is why we want it to be a totally generic way of doing this. Pause the video and have a go at implementing get wheels. Because of the length of the solution, I've decided to roll it into the next video. So I'll see you in there for the solution.